So now let's talk about how to find the length of any line on a graph. For that, let's recap. Now, Pythagoras' theorem is about relating the length of a right angle triangle. So you have one side, side A, side B, and side C. Now it should be intuitive to you that side C is the longer side, and the square of the longer side is equals to the square of the two shorter sides. So we are going to make use of this to create a formula or to derive a formula that talks about how to find the length of any line on a graph. So for example, if we have a graph and we want to find out the length of this line. So for example, this point is 1, 1, and the other point is 7, 9. So this is your graph paper with your usual x and y axis. So if you see this line, you can complete the shape so that it becomes a right angle triangle. And because this is on a graph paper, you know that the length of this line is 9 minus 1, because that's what the coordinates say. So this is 9 here, and this is 1, right? Just reading off the units in the brackets. So the length of the vertical line is 9 minus 1, which is 8. And for the length of the horizontal line, you can apply the same thing. This point is 1, as specified by here, and this point is 7, specified by this coordinate. So the length of the horizontal line is 6, because 7 minus 1 is 6. So if we were to apply Pythagoras' theorem, we know that the sum of 8 square plus 6 square will give me my length here, the hypotenuse of the triangle. 8 square plus 6 square is equals to h square. And if you work it out, this plus this will be 100 h square, and h is equals to 10 units. So using this example, you can derive a formula for all cases. All you have to do is to always take this minus this to get the length of the vertical side, and then you take this minus this to get the length of the horizontal side. So if I were to redraw the triangle in a different graph, but instead of giving it numbers, I call this point x2, y2, and this point x1, y1, I will have my formula if I were to apply the same rules. So the vertical line will be y2 minus y1. That's the length of the vertical line. The length of the horizontal line will be x2 minus x1. So if I were to square this and I add it to the square of this, I will have the length of this line. Let's call this point P. This is point Q. So I will have PQ square. So the length of PQ is simply the square root of y square minus 1 y1 square plus x2 minus x1 square. So if you look at this formula, you have something square plus something square, and you can immediately rewrite it to be this is y2 minus y1 square. It is the same as y1 minus y2 square plus x1 minus x2 square. Now, why is it the same? Because there's a square here, so that if you were to swap these two values, you have a negative sign and the square will get rid of the negative sign. So you can rewrite PQ as this. For example, you are given this question. There are 2 points A and B, and they tell you that there is a point C which they didn't tell you what it is, but it lies on the y-axis such that AC is equals to BC. So find something, but before you come here, you need to find out what exactly is point C. Try to solve this question. If you can't visualize it, it's always helpful to try to sketch, to give a rough sketch so that you know roughly where is point C. So y-axis, x-axis, and we want to sketch, so it means that it doesn't have to be very accurate. So point A is here, somewhere here, and point B is minus 6 and 1, right? So 1 and minus 6. So this is 1, it's minus 6, somewhere here. Okay, so this line AB connects like that, and there is a point here which is point C that somehow cuts in such a way that the length of AC is equals to the length of BC. Okay, so you want to find out what is point C. So the first step now is to write down all the information that you have. So of course the main clue is this: AC is equals to BC. And you also know something about point C. Point C, because it rests on the y-axis, the x-coordinate is 0, as you can see from this graph. The y-coordinate, you don't know what this is, so it is an unknown. Let's call it k. So with this information, we will be able to solve the question using the formula that we learned previously, which is this: the length of 2 points is x1 minus x2 square plus y1 minus y2 square, essentially Pythagoras theorem, right? So this is the length of any 2 points. So since the length of AC is equal to the length of BC, if you plug in this formula to find what is AC and you plug in this formula to find out what is BC, you set them to be equal, you will be able to find out K. So let's see how this is done. Let's work on AC first. So AC is equals to, x1. Now what is x1? You know that the point A is, let me write it here, so minus 3 and 2. So which is x1? Is minus 3x1 or is 0x1? Now the truth of the matter is that it really doesn't matter as long as you're consistent. So if you pick A to be the 1 cases, so if you pick minus 3 to be x1, then 2 must be y1. You can't choose x1 and then 2 to be y2. No, you have to choose 1, 1. Right, so but having chose which is 1, it doesn't matter whether this A is 1 or C is 1. Your answer will still be the same. So let's say we choose A to be 1. So x1 will be minus 3. Now x2 will be 0 square plus y1 is 2 minus, now y2 is k. So k square. So this is what it looks like. We can simplify a little bit. Minus 3 minus 0 is minus 3. Minus 3 square is 9. Plus 2 minus k. Okay, so this is AC. Let's find out what is BC. So BC is equals to same formula. So let's plug in the numbers immediately. B and C. Let me write out what is B here. So let's choose B, the B value, the coordinates for B to be 1. So x1 will be 1 minus x2, which is 0 square plus, so minus 6 minus k square. So it's the same thing. Let's work this out. So 1 plus minus 6 minus k, you can bring out the minus sign, right? I can actually, okay, maybe I write it explicitly. You know, I can have a minus 1 square 6 plus k square here. Okay, if you notice, this thing is equal to this thing. Okay, if you're not convinced, you can multiply the minus 1 inside. Minus 1 times 6 is minus 6, minus 1 times k is minus k, right? And the 2 and the square remains here. Okay, so usually this step, you don't have to write it down explicitly, because if you practice enough, you will be able to skip this. Okay, this is supposed to be an obvious step. So minus 1 square is 1, and 1 times anything is anything, so you don't have to write that. So 6 plus k square. Okay, so this is BC. So the final thing to do now is to solve for k, and since BC is the same number as AC, we can rewrite it to be equals to 9 plus 2 minus k square. Okay, so let's work this out. Okay, so square root some value is equals to square root another value. If we were to square both sides, the square roots will be gone. So 1 plus 6 plus k square is equals to 9 plus 2 minus k square. Okay, open out the brackets using the formula that you should be very familiar with, a square plus, or rather a plus b whole thing square is equals to a square plus 2ab plus b square. So 6 square is 36 plus 12k plus k square is equals to 9 plus 4 minus, so 2 times 2 times k is 4k plus k square. Okay, now you can see that if you minus k square on both sides, this k will be gone, this k square will be gone, so so it's gone. And let's rearrange it so that all the k's go on one side here. Plus 4k on both sides, I have 16k equals to, now let's shift the 1 plus 36 is 37, so let's shift the 37 over to the other side. So you will have 9 plus 4 is 13 minus 37, and 13 minus 37 is minus 24. So solve for k. So k is simply just minus 3 over 2. So you have found out the coordinate of c, and c is 0 minus 3 over 2. Now, unfortunately, this is not the end of the question. They want you to find out the area of ACO, where O is the origin. So we have our trusty graph here. So AC, and they tell you that O is here. Okay, so they want you to find out this triangle, this shaded area here. It's quite tiny, but you can see it. Okay, so the area of any triangle, so triangle area is equals to half times base times height. Let's take OC as the base. So O is at the origin here, so OC at the base, and this base multiplied by the height. The height is the right angle vertical line, right? So you know that the height here, the units, this is minus 3, so the height must be 3 because there are 3 units. So we have to find out what is OC and to multiply with this 3 here. So OC you found in the previous question, because you know that the coordinate of C here is minus 3 over 2. So OC is equals to 3 over 2 just from the drawing here, right? This line is 3 over 2. And the height, this is 3, so you know that the the height is equals to 3. So you can find the area, and your area is equals to half times 3 over 2 times 3, which will give you 9 over 4 units. For this question, you are given a triangle with vertices A, B, and C. So you need to show that triangle A, B, and C is a right angle triangle. So like all questions of this form, the first step is always to try to sketch, so that you will have a better feeling of what this looks like. So A is at 0, minus 5, somewhere here, minus 5. So this is A. And point B is at minus 2 and 1. So minus 2 and 1, perhaps somewhere here. And point C is at 10 all the way out here, and 5, perhaps somewhere here. So 5, 10 here. So this is point C. So let's join the lines to make it a triangle. Okay, this is your x-axis, this is your y-axis. So from this graph here, from this sketch, you can see clearly that this is the longer side. So if this is a right angle triangle, your right angle should be here. How do you solve this? Naturally, for right angle triangles, you can make use of Pythagoras theorem. All you have to do is to show that the sum of the square of this side and this side will be equals to the square of the longer side. So if I were to write it, it will look something like that. AB square plus BC square would be AC square. So as long as this is true, this will be a right angle triangle. So conveniently, you know the formula for the line AB square. The formula for the line AB square is equals to x1 minus x2. Let's choose A to be 1. So x1, 0, minus x2. x2 is minus 2, so minus 2 square plus minus 5 y1 minus y2 minus 1 square. So there's no square root here because you are not looking for AB, you are looking for AB square, which is convenient. So if I were to work this out, it would be 2 square plus minus 6 square. And this will be 4 plus 36, which will give you 40. So let's proceed with BC square. B will be 1 and C will be 2. So of course you can let C to be 1 as mentioned previously, but for the purpose of this working, I'll let B to be equals to 1. So minus 2 is x1 minus 10 x2 square plus 1 minus 5 square. 144 plus 16, and this will give me 160. So AB square plus BC square is 200, 40 plus 160. So if AC square is also 200, I have proven that this is a right angle triangle. So let's take a look at the final step. AC is equals to, so A will be 1 and C will be 2. So x1 minus x2 plus y1 minus y2. Okay, don't forget the square. So you will have 100 plus 100, which is 200. So yay, I have shown that this plus this is equals to this. Equals to 40 plus 160.